Wow, does that little thing cut your fingernails?
Yeah, it does. Actually learned how it works in statics. Oh, it's conveniently written on the board right there.
Oh wow, look at that. The nail clipper amplifies the pressure that you put on both sides by using a simple lever. I wonder how much it amplifies the pressure that you put on each side by. Let's say that I put 1 pound on each side of the nail clipper. How much force would be exerted on the actual nail?
For most machine problems, we can solve it by a very simple method. First, identify two force members. Second, find individual parts and draw free body diagrams for them. Third, draw in support and reaction forces. Fourth, use equilibrium equation to find support and reaction forces. First, we divided the nail clipper into 4 parts and identify part AC is the 2 force member. Wait, what is a 2 force member?
Oh, that's easy. A 2 force member is a member that only has 2 forces acting on the endpoints, here and here. They also go in opposite directions.
The nail clipper can easily be disassembled into a few pieces which we modeled on the board. Since individually each of these pieces are in static equilibrium, we can apply the equilibrium equations to them. The next step is to draw the free body diagrams of all the components that are not 2 force members. These are all drawn right here, and on each free body diagram, the forces created by the other components are also represented on each component, but going in the opposite direction. For example, as the nail clipper exerts a force on the nail itself exerts a force in the opposite direction, which is shown here and here. The forces created with the 2 force member, here and here, are also represented going in the opposite direction as they are on this component. Here's force A. It's shown right here, which is for the top component, and the bottom one is right here, also in the opposite direction. The nail clipper is connected at the very end, and this is represented with Bx on both the top and the bottom, and By on the top and bottom also. Dx and Dy are created from right here when the arm is pressed down onto the top part of this nail clipper.
In order to find the force of the nail, we can look at 2 different parts, either the bottom or the top. All right. Usually, you'd like to go with the part that has the least amount of unknowns. For us, that would be the bottom, with only the force of the nail, force of the 2 force member, and the reaction forces of B along with the pressure applied. But since there's more than 3 unknowns, we cannot start by solving in this part. Instead, we need to look at somewhere else. In part AD, there's only 3 unknowns. So you can use your 3 equilibrium equations to solve for FAC, dy, and dx. If we take the moment at D, we can find FAC, such as here. We have the 1 pound pressure going down in a clockwise direction compared to D. So that is a negative moment 1.5 meters away from the moment origin. Then we look at FAC, which is going in the counterclockwise direction, which is positive, which is only 0.25 inches away. When that's all said and done, you can calculate FAC as 6 pounds. From FAC, we can actually go straight to part CB and solve for F. If we take the moment about B, we already know FAC and can solve for the force of the nail. Looking at the equilibrium equation at moment about B, we have a counterclockwise clockwise motion of FAC at about 1.75 inches away. Then we have a counterclockwise movement of F at 2 inches away. Using our calculations, we found that F was 5.25 pounds of pressure. So applying 1 pound of pressure to both sides of the nail clipper actually exerts a force of 5.25 pounds on the nail and vice versa.